Alrighty. Hello, everyone. I'm Kaelum Hasler. This is Hans. We are both co-founders and designers, engineers here at Rendyr, and yeah, today we're going to be demoing the Optic by making this layered Christmas card right here, and we're going to be making it out of multiple sheets of paper. There's some white paper on the top and the back. And then the middle layers are two different shades of blue paper, and so we're going to be walking through bringing it into Lightburn, actually processing and cutting each layer, and then some design considerations along the way and how that affects things. Alrighty, well, I think we are going to go ahead and get started with the making of the cards, and we'll be answering any questions along the way. Alrighty, so I think that we are going to start front to back. Would it be helpful right now, do you think, Hans, to share this screen?
Yeah, sure. We can show the design.
Okay, awesome. Okay, cool. So pulled up here in Lightburn, it seems as though that is a little bit of an old
You don't worry about it. Don't look at that.
Cool. So pulled up right here, we have all of our different layers that we have in Lightburn, and they're all kind of stacked up on top of each other. You can see over here in sort of the art window that these layers are sort of well, actually, if you notice, they one of which seems to be slightly out of alignment from the other ones. So let's go ahead and fix that real quick.
Yeah, just to backtrack a second. Essentially, what the design is it uses, the layered nature of the paper to show through different colors in different areas, and we have a digital version of this design that is in Lightburn, as you can see. And what we do is we separate each of the different color layers out into different separate designs, and then we take each of those designs, cut it from a sheet of paper, and then when you layer them all together, it produces this effect. So you can see one first layer would have a certain design, next have a slightly different design, and then the bottom layer will have a design that's slightly modified from that.
Alrighty. It seems as though we were just a little bit misaligned, but now you'll be able to see in the preview window over here in Lightburn what we're actually going to be doing today. And so I kind of messed up the ordering over here. I sort of went at it a little bit willy-nilly, but if I had the chance to start this over, I would arrange my layers by the actual noted colors down here in the bottom left of Lightburn in a way that would actually represent the assembly order. So I would make the first layer, what we're doing right now, the white, I would make that blue, and then which one is right beneath it? The light blue. And then the light blue layer of paper, I would make that this red color right here. The third color of blue, I'd make this green, and then the very last one, I would make this yellow. And I think that some of them are in order, but holistically, they're not in order. But we're gonna roll with it. Cool. So I am already connected to the Optic over this data line right here. It's just USB-C on both ends. The machine says that it is ready, and so I think we're gonna load in material and get the machine homed. So first thing I'm gonna do is actually
So we're starting with white?
Yeah, we're going to start with white. We're actually going to lay down the sacrificial piece first.
Sure, yeah.
One of the considerations that should be taken into account whenever you're cutting paper is that all of the little tiny bits of paper, those need somewhere to go once they're actually cut out. And a nice way to lay down a flat surface and keep track of all the little bits of paper is to put a sacrificial piece of material underneath. In this piece right here, we've actually coated both sides in a really low tack adhesive to make sure that if the paper is bent or warped or crooked in any way, that we're able just to lightly stick it down onto the surface. And that prevents the little pieces from flying away, and it makes cleanup generally and moving between different materials a little bit easier than without using a backing material. And so again, that backing material is just a piece of black construction paper to provide a nice surface to catch all the little bits. So we are going to isolate the section that we're cutting first. And so I'm going to turn off all of the layers that we are not currently cutting, just so that we can monitor and make sure that it's doing okay and that we know what we're going to cut. And so if you actually notice up here, the happy and the holidays, the little sections inside of them, like the P and the A and the O, those are absent because what we're actually doing to keep them from falling out is our backmost piece of paper is the same color as our frontmost, so that we don't need to worry about gluing back in those floating components. They're just present by nature of cutting through the other two color layers in the middle. Something just connected to the computer.
Keep going.
Were people able to see this over here, Hans? Okay, cool. Yeah. And so the first layer that we're going to be cutting is this top layer right here. And so I'm just going to put in the paper in the orientation that it is in Lightburn. And I now realize that I put this piece of backing material in the wrong orientation. So I'm fixing that now. And now I'm going to load in this first piece of paper that we want to use. And this is just sort of cream-colored, rather thin construction paper from our local art store, New River Art and Fiber. And so once I make sure that's all in there nicely and flat, I'm using the grid on the cutting mat in order to line it up with 0, 0. And we've chopped down these pieces of paper to be just a little bit larger than what we're going to need for the final product to minimize waste. And what we're going to do first over here in Lightburn is we're going to actually connect to and home the machine. And then we're going to frame our design to make sure that it's actually all in the right spot.
Yeah, let me just put a word in there. I think that our view of Lightburn got frozen there for a second. Mm-hmm. Whoa, doing it again. Fun times. So you might not have been able to see what we were talking about in the cutting software. So our apologies for that. We're working on getting it sorted.
Is it working right now?
Yeah, no, we don't have the view right now of it.
Okay, cool.
So
well, if we get it working, then we'll show Lightburn.
Sounds good.
Alrighty, so I guess I'll just describe what I'm doing. So in Lightburn, what I'm doing now is I am going on over to the move section. I am making sure that the machine is on. It is not on. I am turning it on, and then when the light on the button goes from green to orange, that lets you know that that the motors are engaged and that the machine is ready to move. However, you can be connected and talking to the machine, positioning, working with it when the light is green. You just have to click it and have it become orange in order to start moving and engage the motors. And so now what I'm doing is I am going to hit the home button. And the machine should be humming. Is it? Yeah, it is. Cool. Alrighty. And so the laser module is already focused to the height that we need for paper, but once we get going a little bit, I will take it out and clean it so that I can show you guys the cleaning process of the laser module. I guess before we get started too, we are making sure that our shield is properly and firmly in place, and that our filter is also properly and firmly in place, as what the filter looks like one of the pre-production filters anyways, and it is installed on the right-hand side of the machine, or I guess left-hand side of the machine. And it goes in all the way until it is flush over here. And so since it homed, what I am going to do now is I'm going to tell the machine to frame the design. And so that will let us know whether or not our design is going to fit on the material that we've selected and laid out. So frame. And the machine should be moving, and I can see on the screen that it looks as though our design is going to fit upon the workpiece, or our workpiece is going to fit onto the material. Alrighty, well, I think we're probably ready to start this first cut. Just making sure that it is the correct file. The focus still looks to be the same. Yeah, all right, go ahead, go. See much of it going on. All right, we have our first question. Does it autofocus for different material types? And for the focusing, we'll actually show it here in a little bit. But the way that you focus the material is... Cool, oh wait. Maybe putting this in microphone closer to my side, or maybe we could do where you can put it to the audio situation for a little bit. Just the first one. Just switch the camera travel. Putting it out. Cool. I'll put that down. Are you answering this question? And then we'll just go back to and do maintenance. And then I'll do labor line. Cool. All right. Well, that is the first piece that came out. It's looking pretty good, and we have a few questions in. So first question by Tim. Does it autofocus for different material heights? And Hans, you want to take this question?
I was going to remove this while you
Oh, cool.
answer that. Yeah.
Yeah, so this is the laser module right here. Yeah, Travis, maybe this camera may be actually a little bit better. And so this is the laser module that the Optic uses. And so it's a custom in-house design laser module. And it has this sliding dovetail on the back of it. And it is engaged in this plate right here, which is the x-axis plate. And so this is the plate that moves linearly in the x-axis direction. And that dovetail that is machined into the back side of the laser module has a matching dovetail along the back plate. And they slide together like that, kind of like a quick release plate on a tripod, if you're familiar with that. And so it does not automatically raise and lower per material, but the gauge that comes with the machine right here has these multiple heights on it. And then depending upon the thickness of the material that you're cutting and the type of the material that you're cutting, you would focus the height at one of these steps. And then in order to lock it at that height, there is a lever that is we're losing end caps. A lever that is right here that opens and closes, and then when it is open all the way, the dovetail is disengaged, and then when it is closed all the way, the dovetail is fully engaged. So that means to completely remove the laser module, you open the lever all the way, and then you can just pull the laser module out the front of the machine. To adjust its height up and down, you just loosen this slightly, and then the laser module can slide freely up and down in this direction. And then to lock it into place, you just engage this sort of cam lever all the way, and then that fully engages it and locks it in at that height. And so you can tell what height you need because on one side of the height gauge there are these engraved lines, and then on the other side it is cut all the way through. And so if you're cutting like 1/4 inch or like 1/2 inch plywood or something, you would be using the cutting side. That drops the finest point of the laser about 1.5 millimeters below the surface, and that provides an optimal way to cut thicker materials. And then the topmost one is the finest point at the top of the material, and that is really good for cutting thin sheet material like we're doing right now, and also for detail engraving work.
Yeah, so to kind of pick up that thread there, that's a lot to unpack in just a short little bit, but we're going to have lots of how-to videos on all of this sort of stuff, and we'll explain every single bit of the process in great detail and make it very clear how it all works. It's not that complicated. It's very easy to understand. Yeah, that's pretty much it. Yeah, and then so to, I guess, also pick up on the same thread about maintenance and stuff. So Abby Richter asked, what does long-term maintenance look like for this machine? How long will the laser last, and will it be easy to replace? And I can first answer the easy to replace part. Yes, definitely. So as you can see, this laser module is just a whole module. There's a cable chain that plugs into the end here. If we can get that camera view over there. Yeah, so there's just a plug on the end there, and this is entirely interchangeable. And then in terms of life of the module, what are the numbers on that?
So the diodes that we use are Nichia diodes, which are rated to last anywhere between 10 to 20,000 hours individually. And so placed within our system, we expect them to last somewhere between those two limits. However, we are beginning the testing process to see how long they last in our specific thermal configuration, but we expect to be within that manufacturer's benchmark.
The answer is pretty much non-specifically a very long time. We have only had them fail through extreme torture testing. We have never had them fail through normal use. They are very resilient, and so even though it is easy to replace, it's not something that you would really have to do regularly or even at all during the lifetime of the machine. The laser module is expected to last for the lifetime of the machine. So while you can replace it, maintenance is easy, that doesn't mean it's going to fail. So. Let me go ahead and remove this from the...
Are there any other questions? No, it doesn't look like we have any more questions right now. So we're going to go ahead and pull off this sheet right here, and then we're going to look at it, and then we'll cut the next layer. So this is the topmost layer, and then here is what it's supposed to look like. Hans, you tell me, did we good?
Yeah, I think we're doing
match?
pretty
Alrighty. Cool. We're going to move on to the next layer, which is the
Getting there.
dark blue next.
Light blue next.
Light blue, right below. Alrighty. So this is the nice thing about the sacrificial piece of material. You can just kind of remove like this bit right here, and that is not at all doing what I thought it would. Alrighty, cool. Seems like we cut a little deeper there than I had intended, and we cut
cool,
straight through the sacrificial. It does look cool. So I'm just going to go ahead and remove the little cutout bits. Yeah, that sounds good. That was not the most elegant thing in the world, but we're going with it. Alrighty. And in terms, I think we're going to grab a new sacrificial piece. Thank you so much, Travis.
Looks like we got another question here. How effective is the filter? Let me trade spots with Kim. That's a very excellent question. Sorry about the table there. And how effective is the filter? Does the smoke smell remain? And then also another question on top of that: is any additional ventilation required in an average home? So that's a very good question. That's a fantastic question, in fact. The filter is very effective. So no smoke escapes during normal cutting with the filter. And as far as the smoke smell remaining, that's just kind of part of laser cutting. The stuff that you cut will smell like a little bit burnt, no matter what laser cutter system you use, and no matter what filtration system you use.
Even after it's done cutting.
Even after it's done cutting. However, with the optic, all the fumes that come off the material while you're cutting are captured and filtered. So it's all integrated in here, and no additional filtration system is required with the optic. However, that doesn't mean that you can't use an additional filtration system if you want to. There's a benefit to that as well, but no additional filtration is required just with the base machine.
Yeah, I think Hans was talking about the optional exhaust module, and we will have imagery and videos of that up online here shortly. All right, so we have the second piece of material loaded in. Travis, is Lightburn existent?
And so, since we're talking about the filters, this is what the filter looks like. I can get the view on that real quick. Yeah, and so that is what's in the machine right now. It's basically just a thing that slides in and out.
Yeah. And so just to sort of conclude that, we designed and developed the optics filtration system to capture all of the visible smoke created in the laser cutting process, and all of the fumes created and odors created in the laser cutting process. We can't prevent material from off-gassing, just like with any laser cutter. Once you remove the workpiece from the machine, it continues to off-gas for 24 to 48 hours. And because of that, we do not recommend using the optic in a not ventilated area, or any laser cutter for that matter, because of the nature of off-gassing materials. We are pretty much done with in-house development on the filter, and we're actually going to be working with third-party laboratories in order to get them verified and certified to the proper standards. Yeah, and that's pretty much where we are with that. Alrighty, so in here in Lightburn, I am removing the visibility of the layer that we've already cut, and I am turning on the visibility of the layer directly within it. And that, if I'm correct, is this red layer right here. Yes. And so I'm turning on the red layer, turning off this blue layer right here. Have the material loaded in, optics on. Mm-hmm. Lovely. Just gonna check my settings real quick, make sure that it is all good and the same as it was. And then I am going to go over to the Move tab. I'm actually going to go over to Console. And can they see Lightburn?
Mm-hmm. Yeah.
Awesome. So great. This is Lightburn. Over here, you have the space where you
see what's on that screen there.
Place your artwork. And then this grid right here matches the physical real life grid that you see on the cutting mat itself. And so that makes it really easy to arrange and move your designs around. Over here in Console, I'm going to go ahead and hit Connect because I think we did a power cycle, and we just want to make sure that we're connected. This is actually the optic-specific version of Lightburn, which has these extra buttons here. So we have our fan laser enable, we have at fold position, which goes to fold position, and then Y min, Y max to move the picture. Alrighty, and so what I'm going to do now is come on back over here to Move, and then I'm going to home the machine. Alrighty, and we are homed, and I don't think our height has been adjusted. So what I'm going to do now is I'm going to go ahead and hit Frame, and then that will just ensure that it is still on the piece of paper. Actually, I'm not going to frame. We already did the other one. I'm just going to go for it. And so you will hear the fans in the filtration system kick on for a few seconds before the cut actually starts. And that's just to make sure that they are up to full speed before the laser ever begins firing, to make sure that it is always going to be capturing all of the fumes in the cutting process. And then it does that for a few more seconds after the cut is completed. And that is just to evacuate all of the fumes from the X-axis chamber right here.
It's not playing nice.
We got red light or something? Or...
I think it's
connection. I hit stop, I think. I guess. I don't know.
Yeah, I think if I recall, this particular machine has an issue with the connection onto the laser module. Give me a second.
All right. Well, I could take this time to answer any questions. Cool. Yeah, I will.
We made that.
Totally do that. So, Lightburn is the program that we decided to use for the Optic because it is Lightburn is the tool that we decided to use for controlling and sending files to the Optic because it is currently the most widely accessible and highest quality generalized laser cutting software that's out there. We really wanted to go with an option that would allow anyone to bring in whatever objects and items they wanted into it. So you can just directly drag and drop in an image from Google. You can bring in SVGs, DXFs, any image file, any sort of vector file. And there's also really powerful tools inside of it that you really just don't see in any other laser cutting software. Thanks, Hans. And so,
and looks like we have a comment from Pavel Smoliak, hopefully I'm getting that right, saying that we look very young, but at the same time we're authors of such awesome equipment. Thank you so much. That's great to hear that you like our design. Yeah, it's not just us though. We have a whole team of people working on this. We're not the only ones. There's a whole group behind this thing working real hard to get it out there into the world. Working all the time on all the different aspects of making this a reality.
Alrighty, we're going to go ahead and get this cut started, and we'll answer more questions after it's done. Cool, I think we are ready. It's home, get position, done, start. The audio, you think we could answer the material question?
Oh, we can try.
Cool. Sorry if you guys can't hear too well. We'll work on the audio setup. Next time we kind of place the microphone directly next to the fans, which is the loudest part of the machine. And so the question is from Brooke Lamartina Porsche. Hope I said that right. Does it cut through material, and if so, what thickness? And so that really depends upon the material that you're using. If you are, let's say, making inserts for a toolbox, you could get some 1-inch polyurethane foam and place the Optic directly on top of that foam, and then you would be able to cut that foam and then create toolbox inserts or drawer inserts as an example. And so for like foams and super low density materials like that, the thickest that we've tested is up to about 18 millimeters, around an inch. And then in terms of stepping back from that a little bit, the gantry clearance is about 12 to 13 millimeters. And so that means that with some materials, the thickness depends upon placing it in between the bottom of the gantry and the top of the cutting mat. And so the thickest you could do with that would be like 3/8 or half-inch plywood, 3/8 to half-inch like foam core, any sort of wood and paper products up to about the gantry clearance work really well for cutting. With plastics, because of the nature of the optics laser, it is a laser that is largely within the visible spectrum, and so that means that the color of the material impacts the thickness with which you're able to process it. And so on one extreme, black acrylic, we're able to cut up to 8 to 10 millimeter black acrylic, and then all the way on the other end, clear acrylic. We're not able to cut clear acrylic, but we can engrave it. And so all of the things in between, translucent colored plastics, like your smoked acrylics, those work really well. So you could do like the orange acrylic cuts really well. Red acrylic, blue acrylic, green acrylic, all of that cuts really well. It cuts well at 3 millimeters up to about 5 to 6 millimeters on the high end, and then you can cut more difficult to cut materials like only very lightly tinted materials at thinner levels up to 1 to 2 millimeters. And in terms of metal, stone, and glass, we do not have the ability to cut those materials, but the Optic is actually really good at engraving those materials. And so we have a few samples of that. So we have this poor man who's been turned into a coaster right here, and so this is stone that was engraved. Here's an example of a piece of engraved glass. Shows different. Shows sort of the detail that you can achieve with that. And then, what are we going to throw? Metal? What do we got here? Do we have any metal up here? The production foam, maybe? I'm not sure if we have a sample of engraved metal around here, but that's just another thing that you can do with the Optic is engrave on stainless steel, aluminum, brass, that kind of thing. All right.
Yeah, so we got another great question from Pavel Smolyak. How reliable is the bearing that folds this machine into the working position? Does it require periodic maintenance or lubrication? That is a fantastic question. The bearing, as you were, of the hinge mechanism is one of the most carefully designed parts of the machine. It's one of the most developed parts, for sure, and it's extremely reliable. It basically requires, not even basically, it requires no maintenance whatsoever, and is a really sturdy, resilient part of the machine, I would say.
Can fold it up real quick?
Yeah, we can, real quick here, show what it looks like when it folds.
So the hinge mechanism is actually made up of multiple elements. And so if we're on the side camera, I think we'll actually have an all right view of it. And so, all right. And so there is at the middle of the hinge, the main pivot point, and both the way that it raises and lowers is actually a stainless steel shoulder bolt. And then if we can see up in the top here, it actually tracks within a bronze bushing, which, as you notice, is easily replaceable if it is ever damaged for any reason or if it ever doesn't work for any reason. There's these positive nodes down here, and so these largely engage the most mechanically with the upper hinge plate right here. There is this magnetic snap, which provides some tactile feedback and some, I guess, magnetic attraction between the upper plate and the lower plate. And then there are these gold electrical contacts right here, which transfer all of the power and data up into the upper body. And then when the machine folds, here I'm actually going to take this time to remove this workpiece. Alrighty, so this is layer 2. How are we doing so far? I'm going to set this on top of there. Alrighty, so everything is lining up really well so far. It's a good start. I definitely did the exact same thing that I did last time. So I think for the next one, we're just going to go without the sacrificial material because it doesn't really seem to be working how I thought it would. Still looks cool though, seeing the little pieces left back on the table. Are there any other questions? Hans, would you be able to answer some questions while I pull these things off here?
Yeah. Yeah, so we got another question. What does proper maintenance look like on this laser? Again, very excellent question. That's from Catherine Dennis. Thank you for the question. On this machine, proper maintenance mainly looks like cleaning the lens of the laser. That's, I think, the most important thing. And then, in addition to that, replacing the filter. I'd say both of those are about equal. The filter is very important for keeping you safe, and replacing it when it needs to be replaced is a very critical element of maintaining the machine.
Also cut performance.
Yes, it also, when you have a clogged filter, the machine doesn't cut as well. That's just a fact of life. Then, in addition to that, just keeping the machine clean is good for the looks, but also good for the longevity of the machine, which basically just means wiping down the exterior of the machine, wiping down the cutting mat with water, rubbing alcohol, and it comes surprisingly clean. Laser cutting can kind of be a little bit dirty sometimes, but really the materials that we've chosen for this machine mean that it maintains its good looks even after you've done lots of cutting. You can just simply wipe it down and it's basically back to brand new. I'm constantly surprised at how clean it looks when you just give it a simple wipe down.
Yeah. All of the surfaces that get dirty with soot and fumes are all anodized aluminum and are so really easily cleaned.
Yeah, but other than that, maybe occasionally tighten the belts, but really even that, belts don't really stretch that much, so that's even a minor thing compared to everything else. And then we'll go over a example of cleaning the laser module and cleaning the lens, just to show you what that looks like at the end once we've done the final cut. But yeah.
Oh, and just one last thing to add to that. The Optic uses precision linear rails on both axes. So there's a 12 millimeter rail in the lower body, 7 millimeter rail in the upper body. As with pretty much any CNC machine that has linear rails, they need to be oiled. It really depends upon the frequency with which the machine is used, your environment that you're using it in. But we expect probably about once a year you would use a swab to go over and just put a fine layer of oil on both of the linear rails.
Right.
Let's see.
Dark blue.
Yep, should be smaller little dudes, and then the hole should go all the way through. Mm-hmm. Yeah, I think. Oh, you want them home?
Do we have an orange light on the front?
We got an orange.
Yeah, we're good.
Cool.
So we can hit home on that. And is that aligned with 0?
Should be.
Cool. Then we should be good to go.
All
good to go?
right. I think so. Yeah, we'll see.
Cool.
Do it. Hey Hans, is there a way to pull up an image on like Instagram or something and show through the? Okay. Alright, so we are going to add a little bit to the cleaning question. Just to clarify a few things, all of the basic tools and materials required to keep the optic running smooth are included with the optic in this little tool bag. So inside of the tool bag there is a baggie of optical swabs which you use to clean the laser, and I'll show that here in a little bit. There's also the laser optic cleaning solution right here that you use in conjunction with the swabs. What else do we have in here? The height gauge is inside of it, and then there's a tiny set of Allen wrenches, which would allow you to do any sort of routine mechanical maintenance, like tensioning the belts, as Hans was saying. And then not included in this baggie, but included with the optic are a couple other things. Let me grab them. A couple of other things included in the box is this little skinny Scotch-Brite pad, which really helps to get any sort of residual dust or soot out of the little grooves on the cutting mat. And then a few squares of melamine foam are included in order to help you clean all of the metal surfaces of the machine. And so a wet, I guess, magic eraser is what we've found that works the best at cleaning the metal surfaces. And so I'm just going to show real quick how you would actually clean the laser module. Don't know if we want to clean that laser module yet. It's probably fine to get.
Let's wait until.
Probably fine to get through the next one. So I'm going to start the next cut, and then I'll show the cleaning process.
And just to get some more questions, we got one that says, have we tested any surfaces that are not flat, from John Ong? I did. I don't know if I can recall particularly anything that was super not flat, but I can tell you from my knowledge of the operation of the machine, it wouldn't have any problem working with things that aren't flat. The difference in focus between varying heights underneath the gantry here is such that you could absolutely cut things that are not flat, and also probably engrave on things that are not flat.
Yeah.
We're going to have to do more testing on that to give a more definitive answer, but it's certainly within the machine's capabilities. I don't know exactly how it would behave.
This is how the Christmas card is coming. So just, never mind. This is how the Christmas card is coming along. So we just have one more layer back behind it, and then this one is going to be done. Okay, cool.
And then also, just to get another question, Catherine Dennis asks, how much power does it draw? And the answer is, it uses what is essentially like a laptop charger. So you plug it in over USB-C, and it draws about 75 watts. That's about the total power draw of the machine at this point. It might change a little bit in the future, but right now it's 75 watts.
I was going to grab the power supply, but we don't have an extra one immediately available right now. Alrighty, let's cut the last layer. Okay, so the last layer is just the outline, because we need to cut another piece of white paper to put at the very back of the card. So I'm just clearing off the bed. And then I am placing down another piece of the white paper. Did YouTube ever happen?
Yeah, I think we're back on YouTube now.
Really?
Here we go. Finish up the piece.
Cool. Should I tell Martin we're gonna power through?
Yeah, we can just go and finish up. We're recording still. We can go and finish it up.
Are we back?
Well, for YouTube we are, not Facebook.
Well,
Sorry, Facebook.
Yeah, sorry, Facebook. Hello, YouTube. Alrighty, we are just going to cut out the last layer of our Christmas card right here. And so we have everything except for the last layer of white, and so that's what we're gonna start cutting now. And we'll answer any last questions during the cut.
We might have to save the laser module cleaning process for a future video, unfortunately.
Alrighty, so the last question that I just wanted to add a little bit more information to is the question about power. And the Optic is powered over USB Type-C power delivery, and it ships with a 100-watt adapter. It looks like this. But it is also able to be used with any power supply capable of delivering a minimum of 75 watts over USB-C power delivery. We will probably eventually have multiple laser modules to choose from, and at the higher power levels, if it is above the current power draw, then that would still work with 100 watts, because as of right now, the machine draws about a maximum of 75. So there is a small amount of headroom in the upper limit of power consumption. And that is our last layer and our Christmas card. Alrighty. And then I think we're going to fold up the Optic. I think that's the last thing we're going to do. Actually, Hans is using it as a table. And then we will fold it.
There we go.
And so I don't think that we're going to glue it right now, but you can see that's how the little layered design turned out. And next step would be, gluing it and writing something nice on the back of it and putting it in the mail. Alrighty. Well, I think we're going to finish up here, and we're going to close up the Optic, and we'll show how that process works. So the shutdown process of the machine is really easy. Hit the power button.
Wait. Turn it on.
Oh, never mind. It was already out. You turn it off, and then you remove both cables. So data is transferred and power transferred through the exact same type of cable, exact same connectors on the front. The upper body lifts up, it then rotates, and then the cutting mat itself comes around and just kind of hugs the machine, and then it's out of the way, Optic. We have an Optic, and then it can just kind of chill just like that. Alrighty. Thank you guys so much for joining. Sorry about the technical difficulties. We'll make sure to have that ironed out by next stream. If you're interested, or if you know if anyone would be interested in the Optic, our landing page is active. We're going to be on Kickstarter soon. So feel free to like, share, comment, subscribe. I said it. I did it. All right. Cool. Bye, guys.
Bye. Thank you so much.
Stream is stopped.
Close vMix.
Woo! I'll stop recording.